Kia ora Year 12 and Year 11. This is the first of two videos I'm doing this morning on the difference of two squares. Both of them go with Theta exercise 1506. In this video I'm going to focus on some of the easier examples to get you moving with them, and then I'll do one with the harder ones. They're my own examples, but they're very close to the ones in the textbook. This is something that comes up really often in algebra, and if you can spot the pattern, it will really help you solve more difficult problems. So let's first of all go back to expanding. Let's look at what happens if I expand this. Let's do x plus 3 times x minus 3. So just a straightforward little quadratic. Right, really slowly, what do we get? Well, we have x squared minus 3x plus 3x minus 9. Now this should be really familiar from level 1, hopefully, and we see that we lose our x term and we're just left with x squared minus 9. So if we're asked to work the other way and factorise an expression like this one, we're going to remember what happened when we expanded. That's our clue. So if you're asked to factorise x squared minus 64, we start by noticing that there's no x in the middle, and our next clue is to look at both of these two terms. So this x squared is clearly a square, and 64 is the square of 8. Now it won't always be that simple, but in this case it is. So we put down our two factors. We're going to have x plus 8 times x minus 8, and you can always check that back by expanding. Right, on the next slide I'm going to give you 5 examples to do on your own of increasing difficulty level. So make sure you've got your maths book and try to work through them before you go through my answers. Right, so here they are. So they're all the same idea. Look at the first number, figure out whether it's a square, and get its square root. Okay, pause the video and work through those, and then I'll go through the answers. Okay, well, they can probably just about fit on this slide. The first one is exactly the same pattern that we had above, so that's going to be y times y here. I've got the minus, which is what I need to have this all work. So I'm going to have a plus here and a minus here, and the square root of 81 is 9. So we get y plus 9 times y minus 9. The next one, 25 minus x squared, is a similar idea, but this time I'm going to have 5 here first, and then I'll have plus x and minus x. So if that makes you a bit squeamish, let's just look at expanding that out. Well, we've got our 25 there, and again plus 5x here, minus 5x here, and then minus x squared there. So that works. The next one, x squared minus y squared. Check that I've got the difference of two squares pattern. I've got a square here, nothing in the middle, a minus here, and a square here. So this one will be x plus y times x minus y. Right, number 4. Have I got a square number here? Yes, I have. My coefficient's 4, which is a square, and x squared's a square. I've got nothing in the middle, and I've got a takeaway. 49 is 7 squared, and y squared is y squared. So, well, that y squared is y squared was very profound, wasn't it? 2x plus 7y times 2x minus 7y. There we go. Last one. So when we look at this, there are a couple of ways to do this one actually, just because of the numbers I've picked. But what I want you noticing here is that I've got to always look at my numbers, my coefficients and my constants, to see if there's a common factor. So in this case, there's a common factor of 4, so we'll take that out first. So we get 4y squared minus 100, which is equal to 4 times y plus 10 times y minus 10. The other way to do that, if you didn't spot it, is that in this case, this is the square of 20. So you could have not seen that there was a common factor and proceeded to do this. 2y minus 20 times 2y plus 20. But that's not fully factorised because I've still got a common factor sitting in here. And when we talk in maths about factorising, we mean pulling out all of the common factors as far as possible. So here I'm going to have 2 times y minus 10 times 2 times y plus 10. And once I do that, it leads me back to my final answer of 4 times, whoops, missing a bracket there, 4 times y minus 10, y plus 10. Okay, so that's all I'm going to do now. So you should now be able to work through a fair bit of exercise 1506. I'm separately going to do a video on the perfect square ones. The difference of two squares pattern is so important that I want everyone to have that down really well. So we'll come back to perfect squares in another video. Thanks for watching.